have the function f of x, x the square root of x. And so we don't need this. Maybe I should start from scratch. So f of x, x the square root of x on the interval 0, 1, I think. Yes? I think it's 0, 1. Okay, so first of all, number one, we have to write that f is continuous on the interval 0, 1 because it's a product of two continuous functions on 0 to 1. Product of two continuous functions. Okay, number two, the same differentiable on the interval open 0, 1. Actually, it's not differentiable at 0. As for the same reason, two differentiable functions. So now, by the intermediate value theorem, I have to write that by the mean value theorem, there exists a C in the interval 0, 1, such that f prime of C equals f of 1 minus f of 0 divided by 1 minus 0. So I do have f of x as x to 3 halves. I do have f prime as 3 halves the square root of x. I do have f1 as 1. So this part is 3 halves the square root of c. And this part, f of 1 is 1, f of 0 is 0, and then this is 1. Yeah. All I have to do is multiply both sides by 2/3, and I get the square root of c equals 2/3, and I have to square. So c is 4/9. And this has to be between 0 and 1, and it is. Say it again. Okay. Any questions? Any questions?
If you didn't write stuff too, but if you showed it, is that okay?
I always give partial credit. So
Okay.
good. So let's start with this. Unless you have anything else for me. Do you have other questions for me, or do we start with this? Is there anything else that you would like us to go back to at this moment? Okay. So of course, I don't have all your tests, so I did not grade your tests yet. But I will return them on Thursday, and in the meantime, I will post solutions. Okay, so let's start with the first problem. Let's work on the first problem for 1 minute, see what we remember, and then we'll do it together. Ashley, you don't have this form?
No. I took it.
Okay, that's the last one I have, other than the one I'm working with. Yep, that's it, the last one. So here we have a particle that is moving with the given data, and we're asked to find the position of the particle, meaning the distance function. And we're given the acceleration and some information. Can anyone just give us an idea of how to start? Very good. So find v of t. So take a moment and find v of t. That's our first step. Can anyone give us v of t?
Sine t squared plus 3 halves sine t squared plus 3.
Wouldn't it be 10 cosine t minus 3 sine t?
10, but negative. Because when I differentiate cosine t, I get negative sine t, but this is positive, so that's why this has to have a negative in front, right? When I differentiate this, I get negative cosine. Negative cosine times negative 10 will be that.
Oh, negative cosine.
Is that clear?
I still don't understand why it's negative.
So when you differentiate cosine, what do you get?
Negative sine.
Right, times negative 10 will give you 10 sine t, right? Is that better? Perfect. And then,
Minus.
No, because when I differentiate sine, I get positive cosine.
Plus.
Yes, excellent.
Plus C.
Excellent. Very good. Always take a moment and differentiate and see if you get the starting point, just in case. Good. I don't have any information about v of t. So I have to continue to directly to s of t, and I will call this C1, or you can call this one C and the other one D, whatever you want, or C1 and C2. It's up to you. So can anyone give us the next step?
Equation.
So,
So negative 10 sine t plus or minus
yes,
3 cosine
yes,
plus c1 squared, or yeah, c1 t, right?
Plus C2, yeah.
very good. Everyone agrees with the antiderivative. Now, take a moment and just differentiate this and make sure you get that. So there is no mistake. When I differentiate sine, I get cosine times negative 10 is that. When I differentiate cosine, I get negative sine times negative 3 is that. When I differentiate C1t, I get that. When I differentiate C2, I get 0. Good. So now we have two unknowns, C1 and C2, and we have two equations, or two conditions if you want. So S of 0, when I plug in 0 in t, what do we get? Excellent. When I plug in 0 in cosine, yes, times negative 3. When I plug in 0 in C1t, 0 plus C2 equals 0. Therefore, C2 must equal
0.
Everyone in agreement? Say no, and I'll go back to it. Is this okay? Yes, Ricky?
How did you get C2?
Okay. I have the condition that S of 0 is 0. So everywhere I see t in S, I have to plug in 0. Sine 0 is 0. This goes away. Cosine t, cosine 0 is 1, times negative 3 is negative 3. C1 times 0 is 0, plus C2 equals 0. Therefore, C2 equals 3. Looking for someone. Okay, so now we have S of t, negative 10 sine t minus 3 cosine t plus C1t plus 3. This is what we have so far. But we have another condition that says that S of 2 pi equals 12. This condition is given in order for us to determine
The distance.
C1. C1.
Could you
Okay.
start it with that condition?
I don't have it. If I don't create S, if I don't create the distance, I cannot plug in. I don't have S. I'm given the acceleration, I can find the velocity, and only at the end I can find the distance.
Like when we plugged in 0, could we plugged in 2 pi instead first?
Yeah, that's fine. Yes, of course. Yeah, I started with the first one, but you're right. Yes, we can start with 2 pi and then, yes, absolutely. I thought the question was to plug it in V. My apologies, I misunderstood. Very good. So then let's plug in 2 pi in sine.
Negative 2.
2 pi in sine.
0.
Yes, it's like plugging in 0 in sine. Same thing. 2 pi or sine or 0, same thing. Good. So this is 0. Now 2 pi cosine 2 pi. It's like plugging in 0. It's the same. Yes, it's 1. Still negative 3. Now I plug in 2 pi here, so I do have 2 pi C1 and plus 3, and this must equal 12. So when we plug 2 pi in sine, we get 0. When we plug 2 pi in cosine, we get 1. 1 times negative 3 is negative 3. I have to replace t by 2 pi, and I get 2 pi C1, and then plus 3, and it says that S of 2 pi is 12. So these two go away. So therefore, C1 equals 12 over 2 pi. I will only simplify by 2. So C1 is 6 over pi. So now I have the position formula or function So that is S of t equals negative 10 sine t minus 3 cosine t plus 6 over pi t plus 3. And this is the only function that fulfills all given conditions, including what we call boundary conditions. Any questions on this problem? We remember doing this in class? We had at least, okay, good. So let's move on to problem 2. Let's work on problem 2 for a minute. I would like to assign like 7 to 10 problems for Thursday from chapter 5, so we can go over them in class. So I will not grade that. I will give everyone 100% on that homework, but I will encourage you to work on it, and we'll work on it in class. Okay, so I will take 10 problems, 8 to 10 problems from chapter 5.
If we did that, we get extra.
Yes, you get it.
Nice to credit.
Okay, you too.
Yay.
Okay, so we're working on this. It says, find the areas of the graph of the function on the interval 0, 3. So I hope you appreciate it's 0 to 3, not 1 to 3, because that's when you know it's more difficult. Use the limit of the Riemann sum, and then you can check the answer with a definite integral. So let's work on this. 1 minute. What I would do immediately, I would determine the definite integral. I will calculate the definite integral right away, so I know what to expect. You don't have to. You can just do the limit of the Riemann sum first and then find the definite integral. That's fine too. But I will calculate the definite integral first. Can anyone tell us what we need to determine first?
Delta x.
Yes, delta x. Second,
Xi.
xi. And third,
Yeah.
f of xi indeed. So these are the 3 preps. Delta x, xi, and f of xi, without which we can start the limit. So let's determine those. Can anyone give us delta x?
3 minus 0 over n.
Excellent. Can anyone give us xi?
3i over n.
Very good. Can anyone give us f of xi? Just the preliminary step. Not all the calculations just yet, just for everyone to see.
Well, it's just 3i over n, but in place of every x, so 3i
Over n,
cubed
very good,
plus 6 times 3i over n. Plus 6.
very good. And let's simplify it as much as possible, and then we can put everything together to find the limit. Yes? Repeat? the formula for delta x is b minus a over n. So, over n, that's delta x. Yes, the number of subintervals. There is no m here, they're all n. They're all n. That's okay. The definition is a plus I delta x. A plus I delta x. Yep. So when we simplify this, what do we get? The first term.
Create 27 I over n plus 18.
Very good. Good. So now we can put everything together. And we have to remember that the area, the exact area, is first of all the integral from 0 to 3 from x cubed plus 6x plus 3 dx. But we are asked to find the limit as n approaches infinity from the sum from I equals 1 through n from delta x times f of xi. And as I said, I would have calculated this first to see what I get, and then I would have determined the limit. So you want to do this first, or you want to continue with the limit? Oh, I'm sorry, this one or this? The limit? Okay, perfect. So this is limit as n approaches infinity. Delta x does not depend, I'm trying to cut back on writing, delta x does not depend on I, so I can put it in front, which is 3 over n. And now when I apply the sum to this piece, let me write it first so everyone to see. So this is 27I cubed over n cubed plus 18I over n plus 3 from I equals 1 through n. Then we will separate the sum into 3 pieces. So the sum of the first plus the sum of the second plus the sum of the third. But when we do that, we will take the constant already in front of the summation notation or sigma notation. Just because we want to cut back on writing a little bit. But you can say, no, do it in 2 steps. I will do it in 2 steps. You decide. 2 steps. Perfect. So then we have limit n approaches infinity 3 over n. And then I have the sum from 27I cubed over n cubed plus the sum of 18I over n plus the sum of 3 from I equals 1 through n, from I equals 1 through n, from I equals 1 through n. And now the constant goes in front of each, like we just did with 3 over n. So this piece goes in front because it's a constant, it's a factor, and it does not depend on I. And this, which is 3 times 1, this number goes in front. Is everyone okay so far? Yes? Any questions? Any questions? So then I have limit n approaches infinity 3 over n, and I'm writing it again with 27 over n cubed in front, the sum of I cubed, plus 18 over n, the sum of I, plus 3, the sum of 1. And of course, from I equals 1 through n, I equals 1 through n, I equals 1 through n. At this point, we have to remember those 4 formulas. I call them formulas, they are actually identities. We have to remember what this is replaced with, what this is replaced with, and what this is replaced with. This first part is n plus 1 over 2, everything squared. Luckily, this one is the same thing. but not squared. And this one is n. But we have to remember these four. We have a formula for I cubed, or an identity for I cubed, one for I squared, one for I, and one for 1. We only have a total of 4, out of which 2 are very similar. The one I squared is the most difficult one to remember. N plus 1 to n plus 1 over 6, sorry. So let me write it on the side, but this does not come into play for this problem. So the sum of I squared and n plus 1 to n plus 1 divided by 6. This is not for this problem, though. We don't have any term with I squared. So it's n plus 1 to n plus 1 over 6. Okay, so now we will have 27 over n cubed times this. 18 over n times this. 3 times this. Let me know if we are ready for the next step. Are we ready for the next step? Yes, Freda?
So those identities are for I cubed, I, and 1?
Yes.
Okay.
This one is for I cubed. This one is for I squared. This one is for I. And this one is for 1. Yes, Jared? You want to say something?
No, I was just saying, can I get a little more time copies down?
Yeah. So in the next step, please continue by replacing these. But when you write n plus 1 squared instead of the sum of I cubed, please write it as n squared and expand this as n squared plus 2n plus 1. That makes it a little bit easier. So limit as n approaches infinity, 3 over n, 27 over n cubed times n squared plus 2n plus 1 over 4. Plus 18 over n times n plus 1 over 2, and plus 3n. Is this okay? Is this okay? So I will only simplify, so I will simplify here the n squared. I will leave alone the 4n, but since this is only 2n, I will have to multiply the numerator by 2 and this by 4n because it has denominator 1. So then the next step is limit 3 over n. The least common denominator is 4n. I will distribute 27 to these three terms. So we get 27n squared plus 54n plus 27. But now I have to distribute 36n to n plus 1. So plus 36n squared plus 36n. And the final term is 12n squared. 12n squared. What is the next step? What will be our next step? Combine like terms, of course. We have to combine like terms, and let's do that. So this is limit n approaches infinity. The denominator now is 4n squared, 3, and parentheses. So 27 and 36. 63? Oh, I'm sorry, I forgot about this 12. So it's 75. Sorry, it's up there. So 75 n squared. And then 54 and 36. That's 90. Very good, thank you. And then plus 27. Can anyone give us the final answer, or you want to go through steps? If we go through steps, we will distribute 3 to all 3 terms and apply L'Hopital's rule. If we go through pre-calculus, we know that same degree over same degree when n approaches infinity is the leading coefficient over the leading coefficient. But we're not in pre-calculus, so let's distribute first. So this is limit n approaches infinity. 225n squared plus 270n plus, I think it's 81, yes, divided by 4n squared. It's infinity over infinity. The answer obviously is 225 over 4, but let's say we don't know that. So we apply L'Hopital's rule, limit n approaches infinity. So this is 450 n plus 270 divided by 8n. We continue. It's still infinity over infinity. Limit as n approaches infinity, 450 over 8. So that is 450 over 8, which is 225 over 4. Now we should check with the integral from 0 to 3 from x cubed plus, there was 3x cubed, right? No, it was x cubed plus 6x plus 3 dx. Which function prime is x cubed? Yes, x to the 4 over 4 plus 6 plus 3x. And this is from 0 to 3. Luckily, we don't have to plug in 0 because everything will be 0. So let's plug in 3 and see what we get. So 81 over 4 plus this is 9 times 3, 27, and plus 9. The least common denominator is 4. So this will be 81 over 4 plus 36. So I multiply 36 by 4. So 81 plus 'So I get 5, I get 2 and 1, 225, oops, over 4, as expected. We're expecting a 225 over 4. Any questions on this problem? Anything? Okay. Anything on the limit of the Riemann sum? Okay, moving on. Yes, are we ready? Any questions on this? Anyone? Okay, so let's work on number 3 for a minute. Number 3, find the integral from 1 to 5 from f of x dx, given that f of x is that function. Can anyone give us an idea of a starting point or how to think about this? Or
You split it up into 2 different integers.
very good. So this will be perfect. The integral from 1 to excellent from which function? Great job. Excellent. Plus? Good. So what do we always have to do when we're asked to find a limit? Plug it in to see what it is. what we always have to do when we are determining the definite integral. Careful, that's in the antiderivative. No, the very starting point before I even touch it.
See, it's
Continue.
If it's continuous. Yes, so let's see if it's continuous. So we're talking about the interval for 1 to 4. Is this function continuous on 1 to 4? Yes, it would have not been continuous at 0. So this is safe. Is this function continuous between 4 and 5?
Yes.
Okay, so let's go ahead and find the integrals. Yes,
How do we know to do between 1 and 4 and 5 and 4?
because that's what I have for the function. We read the function. Let's read the function. Blah, blah, blah to the left of 4. Blah, blah, blah to the right of 4. And the integral is between 1 and 5. Better? Perfect. We always read the function to decide what to do next. Okay, so let's determine these two integrals. Let's take a moment and determine them, and then we'll do this together, of course. But just remember, one more time, when we calculate a limit, we have to sort of plug it in to make sure to see what type of limit it is. The same thing here, please remember. Whenever you calculate a definite integral, if it's indefinite, you don't have to worry about anything. But if it's definite, you have to make sure that this function exists and is continuous between 4 and 5. You will see what happens in Calc 2. Those are called improper integrals. When one of the limits is infinity, or both are infinity, or the function is not continuous, it's not different, it's not defined at one of the inside the interval. So those are improper integrals, different types for different types. Okay, so can anyone give us the antiderivative of this? This is a very popular one from the very beginning when we talked about formulas. I said, please remember this one. Excellent, yes, well done. Great job. Plus.
3x squared over 4.
Very good. So this is from 1 to 4, plus. Remember, this is basically x to 1/2. It's easier to use the property when you remember that it's x to 1/2. So it will be x to,
3/2.
very good, over 3/2. And this is, I'm sorry, from 4 to 5. I'm fine if you already know this and do this in your head and you flip 2/3 and so on and so forth. I'm fine. You don't have to do what I do. Use your own method and I'm happy. Whatever works. So then we know that we have to plug in 4. -1/4 plus. So this is 16/2, which is 8. So that's 24. Minus when we plug in 1. In order to be safe, put parentheses because they are sometimes there are many negatives and positives and so on and so forth. It's safer when after you plug in 4, write minus, plug in 1, not worry about the sign, and then at the end you distribute. I recommend this. So when I plug in 1, I have -1 and plus 3/2. And then I'll come back to it later. And then this is positive 2/3. Leave the constant outside and just write 5 to 3/2 and -4 to 3/2. Now, I am more than happy if you say, and it's sometimes easier for me to give partial credit. On the test and the final exam, when you calculate the definite integral, and do not do the arithmetic, I'm fine. I mean, this can be plugged into the calculator. I don't really care for the final answer. So just show me how you plug it in and the numbers, and then the final answer is not really important. If you agree with that. Or do you want to continue? I will continue right now, but during the final exam or test 4, I don't really want you to get entangled into arithmetic and adding and subtracting fractions. Does it make sense? So you can leave it as is, as the final answer. I will finish it though, myself, here. Is that okay? Okay, so you can finish it if you have time. If you don't have time, I'm fine. So now this is negative 1/4 plus 24 plus 1 minus 3/2, and then plus, now this is 5 the square root because it's 5 to 3/2, which means the square root of 5 cubed, which means 5 the square root of 5. So 2/3 times 5 the square root of 5 is 10 the square root of 5 over 3. And then minus, this is the square root of 4, which is 2. 2 to the third is 8. 8 times 3 is 16. So minus 16/3. Yeah, this is, I don't want you to waste time on this on a test or final exam. Okay, so let's see what we have. So the least common denominator obviously is 6. I'm sorry, I have a 4 here, so it's 12. Okay, so this will be 25. So 12, so this needs a 3, this needs a 12, this needs a 6, this one needs a 6, and this one needs a 6. See, this is what I'm saying. I don't want you to waste time on this. It's not important. Okay, negative 3 plus 25 times 12 minus 18 plus 60 the square root of 5 and minus 96.
The last two only 4.
Not by 6, 'cause 6.
Oh, yeah. So sorry. I'm rushing right now. Sorry. Thank you. So this is 40. And is it 64? Yes. That's what I mean. I don't want you to waste your time on this. So if you can give me these 4 numbers. I didn't pull my calculator up. So negative 3 plus 25 times 12 minus 18 and minus 64. Negative 3 plus 25 times 12 minus 18 minus 64.
I got 213.
Okay. Very good. Moving on to problem 4. Evaluate integrals or find the general indefinite integral. So in this case, it's a definite integral. We'll find the integral. In part B, still a definite integral. In part C, an indefinite. In part D, an indefinite. Part E, definite. Part F, definite. So let's work on 4. 1 minute. Bless you too. Thank you.
I thought indefinite
Yes?
integrals didn't have the interval.
Yes, this is definite. That's why it has limits of integration. This one is indefinite because it does not have limits of integration. Yes? Yes. One is the lower limit and 4 is the upper limit. Yes. Then it's a indefinite integral. The definite is a number. The indefinite is a function. Yeah. That's why you will not have limits of integration for indefinite, because the answer is a function. think we're ready, right? Yes? Okay, so then we have the integral from 1 to 4, from 5 minus 2t plus 3 squared dt. Okay, so this is 5t minus 2t squared over 2, which is t squared, plus 3t cubed over 3, which is t cubed, from 1 to 4. So as I said, I am fine if you just write this, and you will get full credit. 5 times 4, 20, minus 16, plus 64, minus 5, minus 1, plus 1. If you stop right here and come back later if you have time, and if you want to finish it and get a number, I'm fine. But I don't want you to spend time on this. Okay? So I will finish it up because, okay, 20 minus 16 is 4. So this is 68. 68 minus 5 is 63. So in this case, it wasn't too bad. But when you have a lot of fractions and stuff, I don't want you to spend your time. Okay, is this clear? Is this okay? Any questions on this? Yes, please. Ashley, go ahead.
How'd you get T? Just T.
Okay, t cubed over 3 prime is t squared. So this piece is t cubed over 3, but I have a 3 in front.
Okay.
That will go away.
Okay, thank you.
Sure, thank you. Is that better?
Yeah.
Perfect. So we are moving on to part B. Other questions here? Everything okay? Other questions? Okay, part B. Still a definite integral from 1 to 2, 3 pieces. So the integral, I forgot to ask here, I should never forget, is this function continuous on the interval 1 comma 4 and defined, in other words, because if it's continuous must be defined? Yes? Yes, it's a polynomial function. Good, the same question here, 1 to 2, 2 over 1 plus x squared, minus 5 to the x minus 2 over x. If the function is not continuous, for whatever reason, not defined or something, only the interval 1 comma 2, I would write fundamental theorem of calculus not applicable. And I'm done. Okay, so do we have a function? Is this function continuous on 1 comma 2? This is continuous everywhere, it's never undefined, and this is not continuous at 0, but 0 is not between 1 and 2. Good. Which function prime is 1 over 1 plus x squared? Excellent. Minus. We'll talk about it in a minute. And minus 2. Very good. Absolute value. And you can say absolute value. There's no need for absolute value between 1 and 2. Agreed. But the first step, I have to write it from 1 to 2. Okay, so let's discuss this for a moment. When we differentiate e to the x, what do we get? Right, but I claim that we should write this. But we don't, because this is 1. Now, if we differentiate 5 to the x, what is the answer?
5dx.
Right. So that's why when we differentiate this piece, we will have 5 to the x times natural log 5 that will simplify with this, and we recover 5 to the x. So please remember that. Okay, I know we're not finished here, but let's make sure that everyone understands this. Arc tangent prime is 1 over 1 plus x squared. Agreed? We remember that? Okay, we already discussed this. Natural log of the absolute value is 1 over x. Of course, times negative 2 in front. Now, I will plug in 2 everywhere and then subtract when I plug in 1. Ready? 2 arc tangent 2 minus 25 over natural log 5 minus 2 natural log 2. Of course, there is no need for absolute value anymore. Now minus, put in parentheses so we don't forget anything. 2, but I know what is arctangent 1. Which angle has tangent 1?
5/4.
Excellent, 5/4. So 2 times pi over 4 minus 5 over natural log 5. And when I plug in 1 in natural log, what will this be?
0.
Excellent. So, of course, you don't need to do anything else. Yes, you could simplify this a little bit and distribute. You can. I will do it. But on the test or final exam, I'm not testing arithmetic. I'm assuming that you passed that already. 2 arctangent 2 minus 25 over natural log 5 minus 2 natural log 2 minus pi over 2 plus 5 over natural log 5. That's the only thing I can still do, nothing else. So this is 2 arctangent 2 minus 20 over natural log 5 minus 2 natural log 2 and minus pi over 2. Are we ready?